as the chair just said, my name is James Osborne. I'm a research entomologist at the London School of Hygiene and Tropical Medicine. I also work for a company called the Arthropod Control Product Test Centre, also known as ARTEC. So today I'll be talking to you about treated materials as personal protection against Aedes mosquitoes. Firstly, I'd just like to introduce you to ARTEC. So we're an independent testing centre based at the London School of Hygiene and Tropical Medicine, and we specialise in testing and evaluating vector control tools for outdoor transmission. So this includes topical repellents, spatial repellents, repellent and insecticide treated clothing, which is what I'll be talking to you about today, as well as traps. We have a whole wealth of expertise at London School, loads of people who are trained in clinical trials, medical entomologists, and also clinicians as well. Being based at the London School, we have world-class facilities, great insectaries and labs. We have specifically designed areas for us to test repellents in for our clients. We also had semi-field free flight rooms, and we also have field sites around the world in which we can test products for our clients. So this allows us to test products from the petri dish all the way up to full-scale field trials. So, sort of recurring theme we've been speaking about Aedes mosquitoes is the problem of controlling them. And we know they're aggressive biters, really anthropophilic, bite during the day, bite during the night, indoors and outdoors. And this creates a problem, especially with outdoor biting and during the day. So current protection technologies such as IRS and bed nets aren't that good at protecting people who are obviously outside of those technologies during the day, working, for example. And this is where repellent technologies and treated clothing can come in. So there is evidence for treated clothing working previously. So we've seen a large reduction in malaria transmission in Kenya, also in Afghanistan for refugees, and also for leishmaniasis, 75% reduction for soldiers in Colombia. What's interesting about all these papers and all these trials is that all these individuals are soldiers, refugees. They're sort of people who are high-risk groups, and that's something to keep in mind and something I'll come back to later in the presentation. So London School and ARTEC, in collaboration with the Dengue Tools Consortium, helped run a trial using permethrin-treated clothing as protection against dengue infection in school children. And this ran in parallel, so London School provided lab testing and ARTEC as well, whilst our collaborators out in Bangkok, Mahidol University, ran the clinical trial. And throughout the process of Dengue Tools, we relayed information to them and they relayed information to us, and we tried to develop the clothing and then at the end run a clinical trial based on using the best clothing we could. So for those who aren't in this field, the way we test clothing is mainly using WHO cone tests and also arm and cage repellent tests. And the cone tests look at knockdown and mortality, whereas the repellent arm and cage testing looks at more biting protection and landing protection, and these are the kind of tests we use to evaluate our clothing. So firstly, we perform cone tests on two different ways of treated clothing. So one way is called the microencapsulation technique, and the other is called factory dipping. There's a reason there are three bars on this graph is because we tested off-the-shelf bought clothing from the manufacturer, but we also sent high school uniforms to them to treat. And we wanted to make sure that there was no difference in the treatment process between the high school uniforms and the off-the-shelf bought clothing. And as you can see from the two bars, the blue and the black bar there was no difference. And this factory dipping technique also seemed to be the best type of clothing to test. So we took that forward. At this point, the trial began out in Thailand. So the trial was a cluster randomized, double-blinded crossover school-based trial in 10 schools in Thailand. Over 1,800 children were recruited, and it ran during the school term, so it ran from June to November. Blood samples were taken at the beginning and end, and serology was used to detect dengue infection. During this time, mosquito collections were also performed in the schools each month throughout that time. So this trial began. Meanwhile, back at the London School, myself and Dr. James Logan, who headed this project, continued testing this clothing in the lab. So we took it a step further from repellent clothing and from repellent testing and cone tests to our free flight rooms based at the school. So the free flight room at the school is 2 rooms, which is connected by a single door. The participant will wear the clothing and sit in one of the rooms, and most of the time that was me, unfortunately. We release mosquitoes into that room and allow them to behave as freely as they could. And we've done 2 experiments, and we tested the clothing in 2 combinations. So the first experiment, we basically performed a human landing catch. So when the mosquito landed, we collected them with pooters and measured protection that way. We also measured biting, so we allowed the mosquitoes to fully feed on the individual. And at the end of the experiment, we looked at the number of blood-fed mosquitoes. And I said we tested in 2 combinations, one of which was shorts and short-sleeved, which is probably more applicable to Thai school uniforms. But we also looked at long-sleeve and trousers as well to see if there was any protection caused by having more material. So landing protection was around 25% for both short-sleeved and long-sleeved clothing, which is relatively low, actually, and we were quite surprised by that. But when we looked at blood-feeding protection, we found a significant difference between the 2, with the full treated clothing providing over 90% protection. And this is probably due to the fact that having clothing, as we all know, prevents mosquitoes from biting through clothing. So that is a reason for that. But what was promising was the 49% protection we found with partial coverage of clothing. So despite having your arms and lower limbs exposed, we were still getting a 50% reduction in blood-fed mosquitoes in these tests. So we've got the results back from the trial, and here are the results, but the 2 main important results are the ones circled in red here. And as you can see, in the control, we had 3.7% dengue infections, and in the treated, in the intervention group, we had 3.2%. So a low reduction in dengue incidence there, in infection. And this was obviously not significant, and this surprised us. But interestingly, what we found at the entomological data was that in the first month, we had a huge decrease in Aedes populations in the schools, so 71%, but this only happened in the first month. So after July, numbers picked back up again, and we weren't really sure why this was happening. So we went back into the lab at the London school and done some more testing on the clothing. And it seems quite simple, but basically what we did was started washing the clothing. And we used 2 different wash techniques. One is a WHO simulated hand washing, which is normally used for testing bed nets. And the other was just a washing machine. And then we exposed mosquitoes to these washed materials, and we looked at the knockdown on mortality throughout the number of washes, so from 0 up to 30 washes. And what we found was that as washing increased, the efficacy of the clothing decreased. But what was surprising to us was how quickly this happened. So the manufacturers of these clothing said that it would last, I think it was over 70 to 80% mortality, up to 80 washes. But as you can see from our graph here, after 10 to 15 washes, that efficacy had dropped well below that. And what was even more interesting was that when we used another washing technique, this decreased even quicker. So it's important to know which washing techniques are used in the field, for example, so we know how quickly this clothing is dropping. So what do we do at this point? We have clothing which does provide protection. This is permethrin-treated clothing, but we know the longevity of this clothing isn't good enough. So what we're currently now looking to do as part of the Zika Plan initiative is look at other repellent compounds, but also look at technologies which can increase the longevity provided or protection provided by this clothing. So there's 3 main objectives in the Zika Plan, in the wearable Aedes repellent technology work package. The first is to perform focus groups, which will be formed in Colombia and also in Brazil as well, I believe. The second is to look at a way to develop wash-in repellents, detergents. And the third is to develop new, novel, long-lasting wearable protection technologies. And these will be clothing, but also other devices as well. So firstly, this qualitative data is incredibly important because if we develop clothing which is the best in the world, if people don't want to wear it, then there's no point in us making it. So we're going to perform focus groups, and as it's for Zika, we're going to be questioning pregnant women, but also men and others as well, seeing what kind of personal protection they're using, if they're using any, what their perception is personal protection, what kind of cost they would put on spending their money on personal protection, but also showing them the products that we would think to use and seeing if they like them, because we have evidence from malaria with rubber tappers in the Thai-Myanmar border. If the clothing is heavy or even not very fashionable, they won't wear it even if it does provide protection. So this is really important data that we need to collect. The second is developing washing detergents. So from my previous data, we saw that as you wash the clothing, the efficacy of the clothing decreased. So is there a way that we can provide detergents that people will use out in the field, that when they wash their clothing, they're washing repellents back into their clothing, and that protection is therefore maintained for a much longer time? And these things can be developed. We've been working with commercial companies at the moment, testing prototypes in ARTEC with various different types of tests. And these things can be developed into a really small package that can be handed out very quickly and distributed amongst the population. The third and probably most exciting is we've been working with collaboration with other commercial companies who are developing technologies which can provide a much longer duration of protection, something that we didn't think was really possible. And this is a way of putting novel silica shells into clothing which contain the repellent, and these are able to last a much longer time. We're also looking in ARTEC developing other wearable protection technologies. People always get bitten on their feet, right? So we're going to look at developing repellent flip-flops. People always get bitten on exposed areas, such as repellent bracelets, repellent necklaces. And we've been speaking to people, and people are very interested in this. Prototypes are available, and we are testing with those in ARTEC at the moment. So in summary, we have these protection technologies available. Obviously they're in development, but they are coming through. The real advantage of these technologies is that they're rapidly deployable. So when I go back to the detergent idea, areas of particular outbreaks or individuals who are at particularly high risk, say pregnant women for Zika, people who, like soldiers who are out during the evening, maybe for malaria control, who are being exposed to malaria-transmitting mosquitoes, these can be distributed to these high-risk groups. And again, with Thai children in Thailand, school children were a high-risk group, and these can be distributed to these people. Again, it can go beyond Zika. As I said, with malaria, rubber tappers are exposed to evening biting mosquitoes when they work, and therefore we can protect these individuals who are at high risk. Also, the advantage of using repellents is that they'll be effective against resistant mosquitoes, which is really important, as we've spoken about for the last day or so. Resistance is a real problem. So using repellents is a way of getting around that. And it's a really exciting time to be part of these projects. Commercial companies are really interested in this. There's more money being invested into these kind of technologies. So it's a really exciting time. There's two final things I would like to mention. As part of Zika Plan, we are developing the Global Vector Control Hub. And we want this to be and this is in collaboration with the Global Health Network, London School, ARTEC, and also WHO are consulting on this as well. And we want this to be like a one-stop shop for vector control information. And we want this to include different vector species present in different countries, diseases they currently transmit, vector control recommendations based on those species. And we also want to include institutes which have specialist facilities and able to test different repellents, different technologies, so people can collaborate more and find it easier to work together with other institutions which have these specialist facilities, which perhaps your current institution may not have. We also want to promote online discussion. People can discuss their expertise, find out what issues they're having, and also develop a big discussion group, which would be great. We also want to have a database of companies, NGOs, who are able to provide vector control tools during our emergency outbreak, whether it is repellents, bed nets, blankets, everything that we can use. So we've been discussing about what the next outbreak may be, and we seem to be one step behind at the moment. So if we can have this database together, with all companies being able to show what they have and what they can deploy quickly, then maybe we can start getting ahead of the game. And finally, I'd just like to mention our online course, Preventing the Zika Virus, Understanding and Controlling the Aedes mosquito. This was developed again with London School and also ARTEC, and also many collaborators in South America, some of which are probably in this room. And I encourage people who are interested in this to sign up. It's completely free. It's on the Future Learn website. We have one course running at the moment, and we have two more running, one in January next year and one in March. So if anyone's interested in signing up, please come and talk to me and I can give you more information on that. And finally, I'd just like to thank James Logan, his research group, my fellow colleagues in ARTEC, and also the Dengue Tools Consortium, Annalise Welder-Smith, and as well Pat from Mahidol University. Thank you.